Well, here's an example.
Will this unit always be this complicated?
It's pretty complicated, but find the charge on the capacitor and the current. That's, in other words, find Q and find I. In the given LRC series circuit, find the maximum charge on the capacitor. If we know that L is 1 Henry, R is 100 ohms, and the capacitance is measured in 4/10,000ths of a farad. And the electromotive force is 30 volts. The initial charge on the capacitor is 0. Sorry, that's the initial charge. Yeah, it's 0 coulombs. The initial current is 2 amperes, and setting up our equation, 1 from this times the second derivative of the charge on the capacitor plus 100 times the first derivative of the charge on the capacitor is 1 over 10 4/10,000ths of the charge on the capacitor, and that's equal to 30. Or, simplifying it, second derivative plus 100 times first derivative plus 2,500 times the function itself equals 30. And the characteristic equation is m squared plus 100m plus 2,500 equals 0, of the homogeneous equation, not the one with the 30, but with the 0 there. So has a double root of m equals -50. And so the complementary solution is C1 e to the negative 50t plus C2 times t times e to the negative 50t. Using undetermined coefficients for a QP, it would be a form just a constant, that's all. Because think of what our E of t is, it's just 30, right? 30. So therefore our YP would be some constant A, which has first and second derivative of 0, so therefore A equals 30 over 2,500, so 0.012. And the solution is therefore Q of C plus Q of P, which is C1 e to the negative 50t plus C2 times t times e to the negative 50t plus 0.012. Now, to find the constants, apply Q of 0 equals 0 and I of 0 equals 2. This is the function itself, and this is its first derivative. You could call this Q prime of 0 equals 2. So, I is Q prime, which is negative 50 C1 e to the negative 50t, that's the derivative of this term. And then product rule will apply to the derivative of this term. Here we got negative 50 C2 times t times e to the negative 50t. That was first d second plus second d first. So the derivative of this times C2t, or sorry, this times the derivative of C2t is just C2. And Q of 0 equals 0 forces C1 to be negative 0.012. I of 0 equals 2 makes 2. By the way, Q of 0 equals 0, that goes back to here. C1 is equal to negative 0.012 because we have Q of 0 equal to 0. So therefore, the C1, which is the only thing that didn't disappear, because when you put in t equals 0, that disappears. So C1 has to be negative 0.12. I of 0 equals 2. This is the I of 0. So put in 0. We got negative 50 C1, and then this is 0. And then we also have plus C2, and that's equal to 2. So negative 50 C1 plus C2 is equal to actually the easy way to find C2 would be, say, C2 equals 2 plus 50 C1. So whoops, that should be 2 plus 50 C1. Oh wait, it's 2 plus 50 C1, but C1's a negative, so I'll go back to what I had there. Sorry. So C2 equals 2 minus 50 times 0.012, which is 1.4. So that means we've got our constants, and the solution to the initial value problem is Q of t equals negative 0.12 e to the negative 50t plus a fourth t times e to the negative 50t plus 0.012. And the I is Q prime, so take derivatives of this. That's 0.6 e to the negative 50t, careful, minus 70t e to the negative 50t, plus, taking a derivative, 1.4 e to the negative 50t. And if you look that this term and this term can be added together, that makes it 2 e to the negative 50t. So it's 2 minus 70t, here's the 70t, times e to the negative 50t. So we've got our I. So the maximum charge occurs when Q prime equals 0. Well, that means when this equals 0, that could only happen if t is 1/35th, right? Because we need to solve 2 minus 70t equals 0. And then the solution for that would be t equal to 1/35th. So after 1/35th of a second, we get the maximum charge. Okay, so maximum charge occurs when t is 1/35th, and we find the maximum charge by finding Q of 1/35th, and that's just a matter of plugging it in to this equation that we've already found. Yes, so Q of 135 is negative 0.12 times e to the negative 50 times 1/35th plus 1.4 times 1/35 times e to the negative 50 times 1/35 plus 0.012. And if you just do the math on this, which is really just a huge arithmetic problem I would do with a calculator, I use my software. And so I got, it's actually 0.01871 blah, 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 coulombs. Right? So that would be what it really is.